Neuroplasticity and Brain Development, a bibliometric analysis of the top 100 most cited articles. Introduction. Hello, I'm Dhruva Bhatt, and I'm the facilitator of this research, and my institution of study is Foothill High School.
Hi, I'm Sia Pandit, co-author of this research, and my institution of study is the University of California, Berkeley.
Hi, I'm Megan Deep, a subsequent author, and my institution of study is Ruben S. Ayala High School.
Hi, I'm Anya Saxena, a subsequent author, and my institution of study is Amador Valley High School.
Hi, I'm Lavi Chaudhary, a subsequent author, and my institution of study is Foothill High School.
Hello, my name is Vivian Porta Chaboya, a subsequent author, and my institution of study is the University of California, Berkeley.
Next, we'll be going into the table of contents. So our research eventually led to these various figures when we will be going over the mapping analysis, senior author distribution, most relevant affiliations, top 8 journals citation distribution, country scientific production, most cited countries, country production over time, and top 8 journals citation distribution. All of these figures were made using data that we extracted and then analyzed. And to provide you with some general research info, our research focused upon neuroplasticity and brain development, primarily extracting data regarding the top 100 most cited articles upon this topic. This information was discovered on the Web of Science database, which includes highly cited and rigorous articles. We then used bibliometrics, an R-based program that allowed us to analyze the extracted data, comparing values and generating figures that made the data comprehensible. Following the figure generation, we developed an abstract regarding our findings, analyzing the results and discovering disparities and trends regarding research surrounding neuroplasticity and brain development. These results were then greater developed in the context of the broad field, allowing us to delve into formulating conclusions regarding this topic.
In Figure 1, Mapping Analysis, we can see that our preliminary research in Web of Science yielded us with a massive group of 7,228 results. Next, utilizing a filter to sift out the top 100 most cited articles, we created a group for an eligible study, as each of these articles had merit in our field. Next, we categorized each of these articles into subgroups, where we discovered that our eligible study consisted of 50 articles, 49 reviews, and 1 editorial material. The majority of cited resources were articles, heavily emphasizing the impact that this research had upon the scientific community. The large number of reviews were also demonstrating the value of resources that evaluate information within this field of study. As seen in Figure 2, within the top 100 articles, we recorded a total of 84 different senior authors, which contributed. Overall, 15 authors published at least 2 or more articles. The foremost productive senior author is Schorner. Schorner is an American researcher who has more than 15 years of experience in conducting research on learning development in attempts to further primary education. She received both her PhD and BA in Human Development from UC Davis and Psychology from Georgetown, respectively, emphasizing the stress the U.S. puts on education and research.
In Figure 3, we can see that the top 3 institutions were the University of California system with 25, Harvard University with 20, and Harvard Medical School with 15. All of these universities are located within the United States, highlighting the concentration of research in this area. The University of California system is comprised of multiple universities, and yet despite this, Harvard itself has contributed almost as many papers, punctuating their contributions to this field of study. Moreover, Figure 4 creates a visual for us to see the top 8 journals cited in the total 100 articles collected. It is evident that these 8 journals are produced from the US, which correlates with the current evidence collected that most cited articles are produced by the Western Hemisphere. This leaves us asking the question of whether the Orient is not being accurately accounted for, or due to lack of resources regarding scientific research are being left behind.
Figure 5 presents a map displaying the level of scientific production in the field of neuroplasticity categorized by country. The United States emerges as the top contributor in research and is then followed by other countries such as Canada, the United Kingdom, and Australia. While a few underdeveloped nations demonstrate significant production of research on neuroplasticity, it is notable that the majority of countries which have high levels of scientific production are concentrated in first world countries located in the West. This further highlights the disparity in the amount of research between developed first world countries and other regions. These findings emphasize the need to expand research to underdeveloped countries in order to promote more equitable research in the field.
Figure 6 helps to demonstrate the most cited countries, which correlates to our previous discussion of scientific production and reinforces our previous point. As we can see through the data, in the field of neuroplasticity, the United States is at the forefront of citations, having produced 47,877 citations into the field. However, looking further, we can see that the United Kingdom, Germany, and Switzerland have also produced papers on the subject. All in all, it seems as though the countries that are the most focused on this topic of research are Western. Future research can focus on neuroplasticity and brain development studies conducted by underdeveloped countries and compare results to studies from developed nations.
Figure 7 shows country production over time and demonstrates the extremely varying distribution of growth between countries. As the United States' increase in scientific production dwarfs that of even other first world countries, excelling at far greater rates than other regions. This continuity and disproportionate growth emphasizes that inequalities within this research persist, and that various groups may be disproportionately represented, once again emphasizing the need for expansion into this field within developing nations. It stresses the need to rise to action, as pursuits of knowledge within the scientific community should not be skewed. Along with this, as our research is based upon the top 100 most cited articles, we can see that Western countries are far more greatly cited compared to other regions.
Figure 8 illuminates the topic distribution that is present in these 100 articles. As we can see, there seems to be a focus on long-term potentiation. This may be due to the fact that long-term potentiation relates to the study of memory, and current research in the field is focused on developing findings in that area. Furthermore, plasticity is also a popular topic. Plasticity also relates to memory and learning, and leads us to further believe that researchers in this field are looking for discoveries related to these concepts. Much of neuroscience is currently interested in the study of aging and how humans are able to store their memory in hopes of elongating human lifespans and memory retention. Our findings, as shown through this figure, provide evidence that this is the direction that the field is heading in currently.
In data table 1, a list of citings is shown. In the table, the first author, senior author, article title, journal source, quantity citation, and distributions are shared. The year range for which the sources came from in table 1 ranged from 1993 to 2017. The citation quantity for table 1 varied largely. The largest citation quantity was 483, while the highest was 168. Though all articles focus on neuroplasticity, each article varies in subsections within this topic. Table 1 illustrates that most of the articles were retrieved from journal Nature. In addition, Table 1 demonstrates that many senior authors collaborated in other articles as well. Data Table 2 is an extension of Data Table 1. Data Table 2 contains first author, senior author, article title, journal source, quantity of citation, and distributions. The year range for data table collection in Table 2 ranges from 1996 to 2015. Once again, in Table 2, the journal source with the most articles was Nature. The amount of citations per article ranged from the 300s to 400s. The lowest citation quantity was 386, while the highest was 483.
So lastly, we will go over our next questions for further research. Are third world countries producing a significantly less amount of scientific articles and research as compared to their Western counterparts? Next, what are the determinants of various countries producing fluctuating amounts of scientific material on various subjects? How does it impact global citizens? And what resources can first world countries provide to help bridge the gap in neuroplasticity research? Lastly, how can we increase diversity in neuroplasticity research, and how do we encourage a greater variety of findings in this field?
Thank you for listening to this presentation. We hope that we've enlightened you on some various trends and possibly inequalities that are present within the field of neuroplasticity and brain development, along with various greater understandings of how we can combat these possible inequalities. And we also hope that our extraction of data and our research has all provided to bring some greater importance and knowledge about this field. Thank you, and we hope that you will work with us to bring equality into research.